I'm from Nanjing University of Aeronautics and Astronautics in China. Today, I will present our recent work that is an efficiency assessment for 16 APR tools. In the literature, research publications about automatic program repair are increasing year by year since 2009. As a commonly studied direction of program repair, generate and validate automatic program repair consists of three basic steps: fault localization, patch generation, and patch validation. In the community, researchers mainly focus on proposing new patch generation approaches to boost automated program repair. By looking at the repairability of APR tools across time, indeed, the number of bugs that are fixed by different tools over the years is increasing. Except patch generation approaches, other studies have been explored to boost APR as well. For example, assessing the over-15 patches generated by APR systems. Explore better test cases for better program repair. Investigate whether APR tools can fix hard and important bugs. Explore the bias caused by the fault localization configurations in APR systems and the overfitting the associated benchmarks. We wonder how about the efficiency of automated program systems. In the literature, the number of validated patches and test time cost has been used to evaluate the APR efficiency. The results shown in this table show that the time cost for validating each core year patch is almost 2 times for validating each chart patch. Such results implies that the time cost for validating different patches for different programs are not consistent. So it is challenging to define a generically suitable time budget for repairing bugs. We further checked the CPU times for compiling and testing defects for J programs on 2 different machines. Such results show that time costs for compiling and testing different programs on different machines are significantly different. So, the time cost is not a reliable metric to enable reproducible and comparable experiments on the efficiency of program repair. Therefore, we propose MPC as the metric for efficiency, the number of generated patch candidates when the first valid patch is found. To assess the efficiency of state-of-the-art APR systems, we select APR tools with 4 criteria: availability, executability, configurability, and standard unknown. Finally, 16 APR systems are selected, which are further grouped into 3 categories by their key approaches: heuristic-based program repair, constraint-based program repair, and template-based program repair. This experiment is conducted with the widely used defects4j box. To eliminate bias from fault localization, all the APR systems are configured with GZOTA 1.7.2. When the patch generated by each APR tool is identical or semantically similar to the patch provided by developers, such a patch is considered or identified as a correct patch. In this study, the MPC scores is counted with 3 kinds of patches. Nonsensical patch. Such a patch cannot make the buggy program pass the compiling process. Implausible patch, which can make the buggy program pass the compile process but fail to pass some test cases. Valid patch, which can make the patched program pass all test cases. Now we first investigate the patch generation efficiency. The table shows the number of bugs fixed by each API tool. This figure shows the NPC score distributions for each API tool. We first found that template-based API tools fix more bugs, but they also generate more patch candidates. We further observed that constraint solving approaches yield less patches, but they need more resources for the patch generation. We further check the differences between the number of nonsensical patches and in-plausible patches generated by each API tool. We observed that some state-of-the-art API tools can avoid generating any nonsensical patches. We also observed that when template-based API tools consider more templates, they will generate more nonsensical and in-plausible patches. If the template-based API systems consider specialized templates, they will increase efficiency by generating less nonsensical or in-plausible patches. We also comparing the difference of NPC scores before generating any plausible patches and before generating a correct patch. These results show that a correct patch can be more efficiently found when the search space is less noised. With this finding, we revised the API performance by setting an NPC implausible patch threshold. We found that after setting such a threshold, 14 of the API tools, their correctness ratio is increased. We further investigate the impact of the localization noise on the efficiency. To that end, we conducted another experiment for the 16 API tools by giving each API tool with the bug positions. We found that when given API tools with bug positions, they will generate less. They will need less NPC scores to generate a patch for each bug. Such results show that false positives of photo localization have a significant impact on the repair efficiency, and accurately localizing the bug can enhance the efficiency. This work is about an efficiency assessment for 16 API systems for Java programs. All the results are publicly available at GitHub. Thank you for your listening.